So welcome back to the page 58 homework, page 58, 35 to 46. In this video, in the last one we had gotten up through 43, so this one we will start with 44. 44. For each of the following graphs with weights, apply the nearest neighbor method starting at vertex A and the sorted edges method to find, it is hoped, a cheap tour, because we don't know, but these algorithms generally return good tours. So, starting at vertex A, the nearest neighbor is going to tell us to take the cheapest edge, which in this case goes from A to C. Then from C we're going to take the cheapest edge, which goes to B. After that, we've gone here and here. The only place left to go is D and back to A. So that would be our nearest neighbor. So 44 A, nearest neighbor, starting at vertex A, tells us to go A, C, B, D. So A, C, B, D, and back to A to complete the circuit. Sorted edges, however, we don't start anywhere. I just look for the cheapest edge in the whole graph, which is still 52. So I will choose that edge first. After that, the next cheapest edge is going to be 65, so I'll choose that next. So, I start here because that's the cheapest, there because that's the next cheapest, and to make a Hamilton circuit, I'm actually out of choices because the only way to complete this circuit is to use those two edges. So that's going to be it. Good, and I don't have to tell the weight, I just have to use the algorithms. So, part B, we're looking at this. For part B, nearest neighbor, starting at vertex A. Starting at vertex A, I will take the cheapest. There's 160, 110, and 330. So I'm going to go from A to B because that is the cheapest. From B, I have 250 and 270, so I'll go to C. And then once I've gone there and there, I have to go to D and back to A. So D, A is where nearest neighbor takes us. Sorted edges, I'm going to look in the entire graph and take the cheapest edge, which happens to start in the same place that we did before. Next, I'm going to take the second cheapest edge, which is different. It's 160 out here. So that's the next edge I take. And then again, there's only one way to complete this as a Hamilton circuit. I have to go there and close it. So that's what sorted edges will return for us. Part C. Nearest neighbor, starting at A. Here's the graph for part C. Starting at A, nearest neighbor, I'm going to take the cheapest edge from A. 99, 78, 93, 103. So I'm going to go from A to D. A, D. From D, the cheapest edge to an unvisited vertex. So 112, 121, or 135. I'll take 112 to B. From B, I've already been to A and D. So I look at 84 and 88. I'll go to C. And then I must go to E and back to A because that's the only place I haven't been. And then I have to complete the circuit. Sorted edges, I'm going to look for the cheapest edge in the entire thing, which is 78. So first I will choose that edge there. Next, after 78 is 84. So next I will choose this edge here. After 84 is 88, which doesn't violate a Hamilton circuit, so I will take 88. After 88 is 93, which goes from A to E, which also doesn't violate, so I will do that. And now, if you look, I have a path that starts here and goes around there like a star. I have to complete that. So it's really going to be the only choice left that completes our Hamilton circuit. I guess to note that I could write it in this notation as well. I'm just doing this because it's the easiest way to look at it. But I could do that. Starting at A, this would go, I could go either direction. I'll choose to go A, D, C, B, E, A. So A, D, C, B, E, A. On the test, if this were free response, you could show it either this way or you could show it this way written out. I wouldn't care which, but you would need to do one of those on a free response. Obviously, if it was multiple choice, I'd probably write it this way to save space on the page, make less copies. Question 45 is a reading monster, but it actually has quite simple answers. So, this represents a town where there's a sewer located at every corner. What they mean is every vertex, where two or more streets meet, and the streets are edges. After every thunderstorm, the Department of Public Works wishes to have a truck start at H and make an inspection of sewer drains to be sure that it's not clogging them. Can we start and end at H and visit each corner exactly once? Well, with these diagonal edges in, this is actually possible. The other thing I'd note is that I have to start and end at H, but if I make a Hamilton circuit, I can start and end anywhere because H has to be visited on it, and then I can just say that I started and ended at H. So I'll start up here because that's my preference and go across. You might not choose this Hamilton circuit, and it doesn't matter. This is just the way I usually choose to do these. But there are lots and lots of Hamilton circuits here. Now, this is where that edge becomes important. And then back up. There's a Hamilton circuit where they visited every corner to check every storm drain. I could look at this as starting at H, coming down and zigzagging, going diagonally, and then up around here, and ending at H. Fine. So, can it happen? The answer is yes. There's the first question. Does this problem involve finding an Euler circuit or a Hamilton circuit? It's a Hamilton. And then, assume equally spaced intervals along the blocks in the graph. There are storm sewers that must be inspected to see if they're clogged. Is that a Hamilton circuit or an Euler circuit problem? Well, it has to be an Euler circuit problem because the storm sewers are along the edges. They're in the along the blocks in the middle of the streets. So along the edges means that would be an Euler circuit problem. And it says find an optimal tour to do this inspection. Well, if it's an Euler circuit problem, then I would be looking at, like, this has valence 5, so I can't do that there. So I would actually have to, like, Eulerize this graph, find a tour, and then squeeze it back onto the original graph, which would be fine, but it's a waste of time on the video. You know how to do those things. So, yeah. Last problem on this homework is problem number 46. Which is here. So, 46. Solve the 6-city TSP problem shown using nearest neighbor starting at vertex A and then starting at vertex B. So, starting at vertex A, cheapest edge, 18, 15, 21, 19, and 9. I will go from A to F. F, I've got 14, 22, 24, and 13. I will go to E. From E, I've already been to A and F, so I'll look at 17, 23, and 12, and I'm going to go to D. From D, I've been to these three vertices. I need to look at B and C, so 16 or 20. I'll take 16 and go to C. And then I have to go to B and back to A, so it doesn't even matter what those weights are. I would choose them regardless to complete my Hamilton circuit. And then starting at B. Starting at B, my choices are 17, 20, 17, 14, and 18. So I'll choose 14, going to F, B, F. Then from there I have 9, 22, 24, and 13. So I'll go to A because that is the cheapest from there. I've been to B and F. So I'm looking at 15, 21, and 19. I'll take 15 to C. So I've been to B, F, and A. I need to go to E and D. So I've got 16 and 23. I'll go to D. And then I have no choices left. I have to go to E and back to B. So E, B. And those are regardless of the weights. That's just to complete the Hamilton circuit. Part B, we're going to apply the sorted edges method to the exact same graph. The sorted edges algorithm says I'm just going to choose the cheapest edges. I think the cheapest edge in this whole graph is 9, so I'll start with that. After 9, I've got 14, 13, 12. So I'll choose the 12. And after that, oh, 12 is down there. After that, I'll choose the 13 because that's the next lowest. So after 12, 13, 14 is here. But for a Hamilton circuit, 14 would put a third edge going into vertex F. So I will not choose 14. 15 goes A to C. So I will take 15. 16 here is fine, so I will choose 16. Uh-oh, and now I've created a circuit, which means I made an issue. So I don't want the 16 edge. Instead, because that 16 edge completed my circuit. Instead, from here and here, I have to go to B and complete my circuit. So I have no choice. Both of those ends have to connect to B. That's the tour we get. I could write it out in the notation for where I started, like A, whatever, all those things. I will assume that you're okay with that. Have a great night.